Hello students, in this video today we will discuss about half range series. In our earlier lectures we find the Fourier series expansion of the functions which were periodic and the interval was given either of length 2 pi or some other length, but function was given over one period as function is periodic and interval was given the whole one period of that function. And here we are talking about half range series. So as name suggests, here we will be provided with half of the period, that a function given over an interval of length which is half of the period. Suppose fx is a function defined over an interval of length 0 to 0, and we have to find its Fourier series expansion. So from the Dirichlet condition we know that the interval must be the one period. So we will define this function over the whole period, and in this way we can extend the function over the interval from -c to 0. It is totally depending upon our estimation. How we can estimate? We will estimate in two ways. First, such that f of minus x is equal to f of x. It means even function, or we can extend the function by reflecting it in y-axis. Students, keep in mind, we will extend our function by taking it as even function in such a way that it is reflecting in y-axis like this. That suppose I am taking somewhat, this is the function over the interval 0 to c, and we will consider we will extend the same function over the interval from -c to 0, that it is reflecting in y-axis, or in this way that f of minus x is equal to fx, that it is an even function, and we know even function that it y-axis give its mirror image if the function is even. Okay. Second way, we can extend our function by reflecting it in origin. What it means? With this way, that f of minus x is equal to minus of fx. That is by taking it as odd function. That is like this. Suppose this is the function over the interval 0 to c, then by taking it as its reflection in origin like this, that it is from -c. So we will extend our function in the interval -c to 0 either as an even function or as an odd function. So students, now we will discuss what we will get when we will extend function as even function or as an odd function. That will depend upon that when you will get a problem of half range series, you will be provided find the sine series, or you will be given find the cosine series. So now we will discuss that if we have to find the expansion of the function as sine series, then we will consider as even function or odd function. Similarly, for a cosine series, we will extend in even function or odd function, that we will check out from our results. So no need to cram. We will discuss here that in every situation we will either extend the function as even function or as an odd function. So we will check it out that if we will extend the function as even, which type of series we will get. When we will extend as odd function, which type of series we will get. So let's check it out. So student, take case 1, that we have extended our function fx is extended over the interval minus c to 0 by reflecting in y-axis. What it means? That is f of minus x is equal to fx, or you may say that is fx is an even function over complete period minus c to c. Friends, check it out. We have taken the first case that we have extended our function over the interval minus c to 0 by reflecting in y-axis. That is f of minus x is equal to f of x. Then our function would be an even function. We already discussed that in case of even, how would be our graph. We discussed it earlier. So first case, that now our function is an even function over the interval from minus c to c. Now we can write its Fourier series expansion, and we know what would be the Fourier series expansion of this function over the interval from minus c to c. It would be a0 by 2 plus summation from n is equal to 1 to infinity an cos of n pi x over c plus bn sin n pi x over c. And we know the Fourier coefficient a0. A0 would be 1 over c integral from minus c to c f of x d of x. What would be an? An would be 1 over c integral from minus c to c f of x cos of n pi x over c d of x. And what would be b of n? That is 1 by c integral from minus c to c f of x sine of n pi x over c dx. Now students, check it out. We already have a property of definite integral, that if a function is an even function or an odd function, then this integral minus a to a f of x d of x, and this is equal to twice of integral from 0 to a fx dx when fx is an even function. So students, keep in mind that if our function is an even function over the interval minus a to a, then this definite integral become twice integral 0 to a fx dx, and it is equal to 0 if our function is odd function. So we will use this property of definite integral here. Here our function is an even function, so this would be equal to twice 2 over c integral 0 to c f of x dx. Here for an fx is an even function. Students, you already know cosine is an even function. Even into even, that would again be an even function. So it would become 2 over c integral from 0 to c f of x cos n pi x over c dx. And for Bn, fx is an even function, sine is an odd function, and therefore this would be an odd function, and this integration would be equal to 0. So in this case, students, a naught, an and bn would be 0 for all n. So from here f of x would be equal to a naught by 2 plus summation an cos n pi x over c, n is equal to 1 to infinity, and pn is 0. So we will get only the cosine series. We will get only the cosine series. And you know what would be a naught? A naught would be 2 by c integral from 0 to c f of x dx, and n would be equal to 2 over c integral from 0 to c f of x cos n pi x over c dx. So student, keep in mind that if you have to find a cosine series when a function is defined over the interval 0 to c and you have to find the cosine series, then we will extend our function as an even function, and we will use the result that fx is equal to a naught by 2 plus summation from n is equal to 1 to infinity cos of n pi x over c. And how we will find a naught and an? A naught is equal to 2 over c integral 0 to c fx dx, and an is equal to 2 over c integral from 0 to c fx cos n pi x dx. So this is called cosine half range cosine series. Half range cosine series. Again, keep in mind that to find cosine series, we will extend our function as even function. So now student, we will take second case, that fx is a function defined over the interval 0 to c. We extend fx is extended over the interval minus c to 0 by reflecting in origin, that is taking it as odd function, that f of minus x is equal to minus of fx. That is like this. Suppose this is the graph of the function over the interval 0 to c. So like that, by reflecting it in origin. We will extend our function over the interval minus c to 0 by reflecting it in origin means we took the odd function. And students, now fx is an odd function over the interval from minus c to c. So you can find its Fourier series expansion by writing f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x over c plus bn sin n pi x over c, where a naught would be equal to 1 over c integral over the interval minus c to c f of x dx. An would be 1 over c integral minus c to c f of x cos n pi x over c d of x, and bn is equal to 1 over c integral minus c to c f of x sin of n pi x over c dx. And using the property again of definite integral, that integration from minus a to a f of x dx is equal to twice integral from 0 to a f of x dx in case of even function, and it is equal to 0 in case of odd function. So students, here fx is an odd function because we have extended it as odd function, so a naught would be equal to 0. Here again for an, fx is an odd function, cosine is an even function, so overall this function would be an odd function, and again its integration would be equal to 0. And here fx is an odd function, sine is an odd function, so fx into sine of n pi x over c, it would become an even function, and using the same property it would be equal to 2 by c integral from 0 to c f of x sine n pi x over c dx. So when we will put a naught is equal to 0, an is equal to 0 for all n, and bn is equal to this, so we will find that f of x is equal to summation n is equal to 1 to infinity bn sin n pi x over c, where bn is equal to 2 over c integral 0 to c f of x sin n pi x over c dx. So in this way you are watching that we would get a sine series. So to find the half range sine series, we would extend our function as an odd function. So students, to get sine series, we will extend our function as an odd function. To get a cosine series, we extend our function as even function. So we can find both sine and cosine series for a function by extending it as an odd function or an even function. So same function can be extended as sine and cosine function separately. So we will take one more example for it. Now suppose fx is equal to x over the interval from 0 to 2. So first we have to find its cosine series. So students, if we have to find cosine series when a function fx equal to x defined over the interval 0 to 2, so we already discussed that we will extend our function over the interval from minus to 2 to 0 as an even function. We will extend it as an even function over the interval from minus 2 to 0. We will extend over the function to make it an even function over the interval minus 2 to 2, and we would get cosine series a naught by 2 plus summation an cos of n pi x over c, and from 1 to infinity, and in this case you are watching that c is equal to 2. So we will get f of x is equal to a naught by 2 plus n is equal summation from n is equal to 1 to infinity an cos n pi x over 2, where a naught is equal to 2 by c integral 0 to c f of x dx, and we know c is equal to 2, so it will become, when we will put c is equal to 2, it will become integral from 0 to 2 f of x dx, and that would be 0 to 2 function is x over the interval 0 to 2. Again an an is equal to 2 over c integral from 0 to 2 f of x cos n pi x over c dx, and students, you know, here in this case c is equal to 2, so it would become integral from 0 to 2 f of x cos n pi x over 2 dx, and during this interval 0 to 2 we are given fx equal to x, so it will be 0 to 2 x cos n pi x over 2 dx, and already we discussed that if fx is an even function over the interval from minus 2 to 2, then bn would always be equal to 0. So students, you can easily solve this integral. This integral is solved by parts, and find the values of an for all n. Here you can find the value of a naught, and in this way we can find the half range cosine series of this function of when it is defined over the interval from 0 to 2. Again, I am taking the second case, that is we have to find the sine series. If we have to find the sine series of the same function, if we have to find the sine series of the same function, that function fx is equal to x defined over the interval from 0 to 2, and we are asked to find the sine series of this function, then we would extend our function from minus 2 to 0 in such a way that function is an odd function over the interval minus 2 to 2. Students, again I am repeating, if we have to find the cosine series, we will extend our function over the interval minus c to 0 in such a way that it becomes an even function over the interval minus c to c. And if we have to find the sine series, we will extend our function from minus c to 0 in such a way that our function fx become an odd function over the interval from minus c to c. So here c is 2, so that's why I have extended our function over the interval minus 2 to 0 in such a way that fx become an odd function. And this, we already said that this is achieved by reflecting in origin, that you can convert this function as an odd function by extending it or by reflecting it in origin. So now our function fx is an odd function over the interval minus 2 to c. Then to find the sine series, we already discussed that fx would be equal to summation from n is equal to 1 to infinity bn sine of n pi x over c, where bn would be equal to 2 over c integral from 0 to c f of x sine of n pi x over c dx, and students, here c is 2, so it would become integral from 0 to 2 f of x sine of n pi x over 2 dx, and during this interval from 0 to 2 our function fx equal to x, so we would get that integral from 0 to 2 x sine n pi x over 2 dx. So now students, you can easily calculate this integral by, you can solve it by the method of by parts and find the value of bn for all n, and in this way we can find the half range sine series of this function over the interval 0 to 2. So students, we can find both sine and cosine series of the same function separately by extending it as an even function or an odd function. So you have not to get confused that how we can find both the series. It is totally upon our extension that we are extending it as an even function or as an odd function, because we are provided over the half interval. So for the remaining half interval, it is our assumption that how we are extending the function, we are extending the function by taking its reflection in y-axis or taking its reflection in the origin. In the first case it would become an even function, in the second case it would become an odd function, and using the property of definite integral we can find the both sine and cosine series of that function. So the same, for the same function we can find both sine and cosine series, but before writing sine and cosine series you have to mention this thing, that how you have extended the function and you have considered it an odd function or an even function over the complete period of. So always mention this thing when you find the sine or cosine series. For cosine series we will extend as an even function, for sine series we will extend as an odd function. So always mention this thing, then write directly the sine series or cosine series and directly these a not an or bn, whatever we will use. So students, in this way we find the half range sine and cosine series of a function when it is given over the half of a period. Thank you.